Hello everybody. We are going to be looking at another truss, and we're going to be computing the axial force in members BD, BE, and CE, and we're also going to note if they are in tension or in compression. Now if you notice, this bridge is sitting on two edges, so we're only going to have vertical forces at A and vertical force at H, which is going to be fine because we have no force in the X direction. So if I was to draw AY and HY, I could compute the reaction forces using the free body diagram. Now what I'd like you to do is pause the video and compute the reaction forces on this truss. Now that you paused the video and you computed the reaction forces, I got this was 32.5 kips and this was 27.5 kips. If you did not get these, you probably want to go back, see what your error was so that you can get these answers. Now, if I want to draw the free body diagram, and let's say I do this, I want to draw the free body diagram. Here it is, and let's go ahead and finish my diagram. So I'm going to draw all of these members here in tension. Now remember, we cut the truss right here, so we're doing the left hand side of the truss. I could do the right hand side. I have an extra force to deal with, but it wouldn't matter. You get the same answers. And something that you might want to do when you're working this problem on your own is compute using the left hand side, the free body diagram on the left hand side of my cut section, and also do the right hand side. You should get the same exact answers for each member and their axial forces. I'm going to give my reaction force here of 27.5 kips. I'm going to go ahead and label all my points. And I'm going to draw the external force at point C. We also note that this distance here is 8 feet. This distance here is, each one of those should have been 17 feet. My apologies that didn't get copied over. So each one of these were 17 feet. Okay. So now that I have my free body diagram drawn, I can also, what I like to do is sometimes I just don't like to solve for angles. So what I'll do is I'll say this is 8, this is 17, and then this is 18.78. All I use is Pythagorean theorem to compute that. Now if I want to, so why don't you pause the video and figure out what you're going to solve, what member you're going to solve by using summing your moment about a point. Alright, now that you had time to think about it, did you sum your moment about point E? Because you have BE and CE both going into that point, and you could solve for BD. Or did you sum your moment about point B, because you get rid of BE and BD, again because they go through that point, they have no perpendicular distance, and you can get member CE. I guess I should go ahead and label these. These are the members that we're solving for. So I summed my moment about point B. So about this point right here. So I sum my moment about point B. Counterclockwise is positive. So I'm going to get that CE, which I'm looking for, times its distance, which was 8 feet, minus, now this 27.5 kips is going around point B in a clockwise fashion. That's kind of funny. Times, this distance is going to be 17 feet. and that's all equal to 0. Now, another reason I picked point B was because I also got rid of this 10 kips because it's going through that point. Computing, using my cool calculator, I got 58.4 kips, and that's going to be in tension. Now I can sum my forces in the y. When I sum my forces in the y, my unknown is going to be BE. I have this 10 kips and I have this 27.5 kips. So BE is going to be negative because it's going down, and that's going to be 8 over 18.78. Again, you could find that angle and use sine or cosine depending on what you solve for. Plus 27.5 kips, which was my reaction force, minus 10 kips, which is the external force acting on the side of the beam, on the side of the truss that I'm solving for. I don't need to worry about this 30 kip that's here because I cut my beam, or I cut my section of the truss here. So BE, remember BE comes out to be 41.1 kips, and that came out to be in tension as well. Now BD, if I sum my forces in the x direction, I have BD, which is going to be positive because I'm showing it in tension. Well, I shouldn't say it that way. I'm showing it in tension, and so when I take my equilibrium equations, it's going to the right, so it is positive in my equation. Plus 41.1 kips, that is going to be BE right here, times 17 over 18.78. Again, you could use your angle, plus 58.4 kips. That was the member CE right here, and I guess we could have wrote those in. That was 58.4, and BE was 41.1 kips. And both in tension, and I'm keeping it in tension. I didn't change the arrow, I kept it in tension. Is all equal to 0. So BD comes out to be a negative 95.6 kips. So that's going to be in compression. So my answers for this problem then are as follows. Each CE and BE are in tension. CE came out to 58.4 kips in tension. BE was 41.1 kips, again in tension. And BD was let's not put negative, let's just put 95.6 kips, and we're going to call that in compression. So I hope this helps. We'll be getting online in class so I can help answer questions. And if you have any additional questions, please shoot me an email or a text. Remember, send it through Canvas inbox. Have a good day.